trigger things for, or all the supplements for iron. It tasted nasty though. Yeah, it was a bummer. Okay. Geoseries, we know exactly what it's converging if it converges, right? A sub 1 over 1 minus r. What else do we know what it converges to? Telescoping. Because telescoping will converge to the first term, well, I say the first term minus the limit of the last term as n goes to infinity, but the problem is that's not necessarily true. Didn't we see some funny telescoping? And just because visual aids are helpful, where was telescoping? The day of the fire drill. Back here somewhere. Well, it's after that, huh? Yeah, I think I passed it. Where is he? Is it comparisons? Ah, there it is. Got it. It looks so easy. Take the first and take the last. Yay! But not all telescoping telescope the same way. That one did, but this, ooh, that guy was left and that guy was left, and then we were randomly taking the limit of that guy. So, guys, remember, when I say telescoping and when I can say we can know what it converges to, it's whoever's left when everybody else is being canceled out or condensed, right? And then the limit as n goes to infinity of whatever part of the expression is left. Anyway, sorry. So telescoping, we know what it converges to. Geo, if it converges, we know what it's converging to, but nothing else. However, haha, he's alive. Hey, bud. However, alternating series. We can estimate. So what's the theorem say? Let's go ahead and label some stuff. I talked about it yesterday. Yeah, right? Okay, it's all right. What's R stand for? What's R stand for? Remainder. Good try. Good try. S stands for the actual sum, the infinite sum. The actual sum or the infinite sum. N stands for the partial, or you can think of the estimate. Not established. Estimate, not established. And a sub n plus 1 is the... Can I just put the next term?
Yeah, sure.
What do I mean next term? If we do the 6th partial sum, it's the 7th term. If we do the 11th partial sum, it's the 12th term. Does that make sense? Whatever partial sum we're talking about, it's the next term. So hold on, I want you guys to take a second. There's a lot of words up there. I gave you the idea of what it's saying. Take a second and read the words, though. I don't necessarily need you to write them all down. And remember, there's a big if. If the alternating series converges, then the truncation error, truncate, cut. Oh yeah, we're only taking so many terms. We're leaving off others. Is less than a sub n plus 1, or the next term. So read the paragraph below. Do you guys see how when it says the sum S, it means the entire sum, the infinite sum, the whole shebang, the actual sum? Does that make sense? The plus ... including that sum. And then partial, okay, that's going to be first 6 terms, first 11 terms, first whatever. Error, ooh, you might want to make a note of this. Remainder could also be called error, how far off it is. How far off it is. Error, remainder, how far off it is. We're talking about absolute value because I don't know if you guys remember from chem at all, but you might have dealt with in labs about the error of your measurements or the things that you found. It could be percentage error, it could be actual error. But generally, you could say it's this far off above, like too high of an estimate, or this far off below, but usually we just say how far off it is. That's kind of the idea of the absolute value. Down below, it's saying the partial sums are going to go a little bit above, a little bit below, a little bit above, a little bit below, because when we add and subtract, aren't we making it bigger than smaller than bigger than smaller? Does that make sense? But somewhere between that bigger and smaller lies the actual. If it's a convergent, But if the series is converging, then the distance it's jumping back and forth is going to 0. So think squeeze theorem. Somewhere in there is the actual sum, even if we can't say exactly what it is. So here's the bottom line. Do you guys already get that? You can get an idea of how close. The bottom line is you can get an idea of how close you are to the actual sum without ever knowing it. So for alternating series, guess what? We don't know them. We don't know what the sum is or the series is converging to. But we can say, oh, it's within 0.0000. Oh, we have a pretty good idea. Does that make sense? Okay. So let's go ahead and play with. Let me have you guys analyze the information on the board, yeah? Let me have you analyze the information on the board. Yeah.
It's within 0.000 what?
The actual.
So like what is with like the term?
Whatever partial sum. So like in this one, that's why we need to get an example. So analyze the information. We have a series. It's an infinite series. True? Going to infinity plus ... We are told take the first 5 terms. So in this case, the first 5 terms added together, that number is within, and we're going to see what it is. Is it within 1? Is it within 2? Is it within 0.5? Does that make sense? But the more terms we add on, we could theoretically, if there's a term down here, that's like 1 over 100. That'd be 0.0. So if there's a term down here that's 1 over 100, 0.01, I can say add up all the terms before it, and it's within 0.01 of the actual. So let's say it's the 12th term, add the first 11. Let's say it's the 5th term, let's add the first 4. Okay. So what are the first 5 terms? Oh, hey, we already have the first 4, so all we have to do is add on 1/5. So 1 minus a half plus a third minus a fourth. One more, right? Okay, so that'll get us our first 5 terms. What is that? Oh, I don't know. But we could do that fairly quickly. Common denominator, what puts it all together? 120? I think. Does 120 get everybody? It gets him, it gets him, it gets him, it gets him, it gets him. There might be something smaller. I'm just going to be lazy. Is that okay? Yes. You want to use 60 instead? 60 minus 30 plus 20 minus 15 plus, oh, brother, 12. You guys agree? 60 over 60 minus 30 over 60 plus 20 over 60 minus 15 over 60 plus 12 over 60. I think we got it all. Okay. So 60 minus 30 is 30, 50, 35. I always hate the 15s. 47. But double check. I don't know. Does that sound good? Okay. So we have the sum of the first 5 terms. The idea is the next second you're going to be subtracting 1/6, which is going to be, oh, hey, nice, 6/60ths, 10/60ths. You're going to be subtracting 10/60ths the next term, but then you're going to be adding 1/7, which is 9, 8 point something 60ths. So you're going to be going down, then you're going to be going back up 8-ish, and then you're going to be going down, then going back up. Do you see how like it's narrowing? So it'd be 60, take away 30, and then no, add 20, no, take away 15, no, add 12, no, take away 10, no, add 8-ish. So that's the idea of, oh, it's kind of leveling out. It's squeezing closer and closer and closer to the actual sum. But it will only squeeze closer and closer to the actual sum if it's what type of series? Convergent. Convergence going closer and closer to a number. Divergent, okay, forget it. It just diverges, stop. How accurate is this estimate? Well, what does the theorem say?
It's less than the next term.
Yeah, it's less than the next term. So remember, what are the ones, just quick recap, beginning of class. What are the ones that we know what they're converging to? Telescoping and geo if they converge. Alternating, do we know what it's converging to? Can we start there? Nope, no clue. But we can say, oh, but wait, there's this cool theorem. And the cool theorem says, however many we add up, the error is less than the next term. So we added up 5. What do we want to look at? Oops, wrong way. We added up 5. Let's look at a sub 6. The absolute value of a sub 6. Hey, isn't that negative 1/6, but we don't really care about the negative? So what's the error? Careful, what's the inequality? Is it less than or less than and equal to? Less than or equal to, okay. So we can say that the error is less than or equal to 1/6, which, help me out guys, is that the 0.166666? Is it that one? Is that 1/6? Yeah, 6 into 10 is 1, and then 4, and it's 40 for forever. So 6. Okay. So how far off are we? Not too far off. But then they say, we want it to be within 0.005. All right. But who do we need to be 0.0005? 0.005 or less than. The next term. Oh, so what do we care about? The n plus first term? Oh, can we make an equation for the n plus first term? Yeah, we can. If they want us to find the error within 0.005, then let's take a sub n plus 1, which we can actually make an expression out of, and let's say, hey, you need to be less than or equal to 0.005, because if you're less than or equal to 0.005, guess what else will be less than or equal to 0.005? The error. So we have to go back up here and say, okay, they give us an equation for a sub n. Oh, well, if that's a sub n, then what's a sub n plus 1? Plug in n plus 1. If you want to think about it, I showed this a little bit at the beginning. I haven't recently. But when you go ... you could do -1 to the n plus 1 all over n plus ... You could say like, hey, here's a few definite ones. Keep going with this pattern and then just keep going. So this is the nth term. Go one more. Guys, do we care about the signs? Nope. So if we don't care about the signs, then forget the -1 to the, he's just the alternator. So who do I care about? I care about the 1 over n plus 1. Less than or equal to 0.005. Is that an algebraic equation? No, expression, sorry, that we can solve? Yep. Why don't we multiply by n plus 1 and divide by 0.005? Oh, that's tough. Can we make him into 5 tenths, hundredths, thousandths? Which would be 1 over 200ths. Are we okay? 5 over 1,000 is 2 over 100. Sweet. So I can multiply and say 200 is less than or equal to, multiply up, n plus 1. So n has to be greater than or equal to 199. The 200th term would be within the right range. So if the 200th term, which is the next term, is within the right range, then what partial sum do I need? S sub 199. I need the one right before. So the sum of the first 199 terms, S sub 199, would be within the acceptable range. Of the actual infinite sum. And before they were asking us for S sub 5, and they were asking us for the error of S sub 5. So do we know exactly what the sum is? No. But do we have a range? Yes. Do we know what the actual sum is? No clue. Do we have to be okay with not knowing? Struggle, huh? Well, in science, in math, is there an acceptable range for a lot of different pieces of data? Yeah. All the way up and through, I don't know, what, like pre-cal? Wasn't an acceptable thing for pi 3.14? How precise was that? But it was acceptable for a while. Now, you needed it more precise eventually, but guys, if we're able to just add the first few or add, okay, the first 199, Is there an acceptable range? Usually. Now, off the top of my head, do I have tons of applications of sequences and series? Nope. Why? Well, I play a little more with the math than I did with the applications in college. Just how it is. Maybe we can go talk to an engineer and be like, hey, is there actually any place that sequences and series come back? Some of you guys are going to engineering school with Mrs. Leon and Mr. T, and maybe me. They can squeeze us in and we all get to go.
Oh, you should tell Miss Leon.
I already did. She's already calling and she's trying.
Yeah, but she's trying to get 12 more spots, but most of us are already in.
There's only 5 of you, though, I think. I counted on the roster.
Well, Aryan's also in AP Biotechnology.
Oh, 6.
So minus 6, so tell me we only need 6 more spots instead of 12.
No. I already minus 6, though. That's the struggle. I minus 5, so we need to minus 1 more, so just 12. But then wait, how about me? Do I count? I want to go.
Aren't there only 12 of us?
No, there's 14 of us.
There's 2 people.
Carrie's not here, and Kathy. No, that's what I'm trying. Because they're going to go visit the engineering school at UCLA, talk to engineering students, and then, or something at USC, something at UCLA. I forget which one's which. USC Med, UCLA Engineering. So I was like, if you're going to engineering, why isn't Calc going? And she was like, oh, I'll try. So Mrs. Leon's trying. She just has to work out. USC said yes, UCLA, verdict's still out, and transportation should be fine. We have enough sports teams going places, but whatever. Anyway, we'll see. We'll see.
CalcBC, they're like, no. They should bring Calc. We do not go in Diva's car. I know we can all fit in my car. Let's all squeeze in my car, guys. Bernie.
Oh, is that why? Oh. Hey. Gas efficient?
You guys gotta give me gas money.
Wait, what's the formula?
That's a good question.
There's no series.
I'm trying to think, but number 31 wouldn't necessarily, was there a number on the last one? No? Okay, no stress. What am I doing right now? Pulling up your book. What section is this, 9.5? Ooh, why is that bad? What's on the backboard, guys? Ooh, good lead-in. 9.6? Is that where we're supposed to be starting today? Huh? No.
What's today?
Next Tuesday.
Wait, I thought the test was on Friday.
9.5, but we didn't finish it.
No, our test isn't Friday. Our test is next week.
Oh.
Pause. Okay, what are you supposed to have finished for tomorrow? The homework that you get to do the remainder error stuff on for today. Now, were you still supposed to submit? Yeah. Remember, I just said you could stop at the remainder. But am I going to be super mad if you show me an excellently, fully attempted homework tonight and you put a comment and say, sorry, but now it's good? I'll probably be gracious, yeah. 9.5 is where we are, but what am I hoping we'll at least introduce today? Section 9.6. Ratio root. Yes. Last section. Wait, a last section. That means the test is coming on. Weekend, remember, so it's not that we're missing Monday. Friday, maybe all of Friday. Basically says, hey, here's lots of series. Can you attack them? And make sure you know all the different tests, which is very similar to your actual test next week. Sound good?
So will that be a review, or do we have that in a review?
I think that's your review. I don't think I give you something from the book. Because that's more than, oh, hey, look, Issa's note. Woo! All right. We're looking at number 31, right? I think it's 2 days. I think it's maybe a part 1, part 2 again. Maybe not again. You guys don't normally get that. One day is going to have some multiple choice and maybe a couple long answer, and the next day is going to be like, hey, here's lots of series. Show me you can do every single test. Not every single series, but pick from the series to show me every single test. Not using any of them twice. Does that make sense?
So there's going to be more series?
Yeah, they're going to be more than 9?
So on your review, I'm not just giving you 9, well, I guess it's 10, 11. I'm not just giving you as many series as you need. I'm giving you more than enough to give you lots of practice. And on the test, all I need to know is, or all I need to see is, where's a P series? Oh, look, you used P series. Good. Where's an alternating? Oh, look, you used alternating correctly. Good. Where's, so you guys might do different. Mm-hmm.
Can we do a test like
I
twice?
thought it was going to be like the questions, yeah, and then I was going to say like if you don't do one, but you still get the answer right. Is it going to be completely wrong?
I'm going to be grading for parting. Did we actually do this? P-A-R-R. Sorry, P-A-R-R-T-I-N-G-C-C. I'm going to be grading 10 problems. So in those 10 problems, part of the points overall will be, did you use all 10 tests? But that's only part. And well, if you only use 9 but you did 10 series, I'll give you for that 10th, you're going to get points for which test and that it checked off one and for doing it right. So if you, does that make sense?
Yeah.
Yeah. Isa. Yeah, I think it's next, Forever Quiz I think is next Tuesday, Forever Endeavor Quiz. And then I think we start the test DEBA Wednesday and then Thursday. I think. Yeah.
So like on the test, if there's like a limit comparison test and we're not sure if we did it right, can we do like 2 using limit comparison and then if we get one of them right?
Then you have to choose which one. I'm only grading 10. And so if you don't like make a note, I'll just grade whatever one I feel like without looking. Yeah. Or you could do one, you're like, oh, this is an easy nth term, and a little bit later you're like, oh, wait, I need an integral test, and I could have integrated that. I'm not going to do nth term. I'm going to do nth term here, and then I'm going to do integral test there. Does that make sense? So there might be some. But that's why we have like a long weekend for you to play with the review and then us to play again on Tuesday after the Forever Endeavor Quiz. Is that cool? Not cool, but it gives you an idea.
And so the Forever Endeavor Quiz is all 70 so far?
No. It's just all the convergence, divergence stuff. Well, and the estimation theorem, but anything from this chapter alone. But it's nice and printed off so that we can do fill in the blank, because having you state a whole test, that there's better uses of your time. Okay, so sorry, looking at number 31, you guys were like, what are we actually doing? Oh, we're doing him. Okay, all better. We're doing him. Okay, so number 31. Determine the number of terms necessary to have the error of the approximate sum of the series less than 0.001. All right, work in your groups. Sometimes when I'm talking, it just gets overwhelming. So let's see what you can do following the last example. Cool? But isn't a sub n like a of n?
That's what I was thinking.
Like f of x?
So it'd be inside. Oh.
Which makes more sense mathematically if you think about it.
For the last problem, when zeros are implied, like they're always going to get that number right. You don't have to find that or something.
If they're asking you to get it to within, then yes. Or they could be saying find the sum. So either they tell you like how many terms to find a sum and then figure out the error, or make the error of this applicable. So you're going from error backwards or from the sum forwards to error. Does that make sense? Yeah.
Less than, right?
Yeah.
Mm-hmm.
Less than or equal to 1 over.
1 over 1,000, right? So 1 over n plus 1.
Oh, you guys should have Kathy today. See if this makes sense. Because I need him to be, I come back up here and say, well, absolute value, I don't care about him, forget him. 1 over n cubed, I need n plus 1 term instead. I need him instead. Cross multiply. I haven't done the math yet, but is it looking good so far in your analysis, guys?
Oh, you could have, because they're both 1 over, you could have just gotten rid of the 1 over.
Oh, I actually, to be honest, I multiplied.
Oh, okay, that's right.
The inequality otherwise could get messed up.
Gotcha.
Does that make sense?
Okay, I was like, did I just waste time?
I cross multiplied.
Gotcha. What was the thing that makes you flip the inequality sign from like the algebra?
Multiplying or dividing by. Got it.
What?
By a negative. Wait a minute. Hold on. Don't we have to plus or minus cubed? Wait. Cubed roots aren't plus or minus. Only square roots, fourth roots. But also, guys, do we want n to be a negative? Ever? Because n always goes from 0 or 1 or 2 to positive infinity, right? N is which term? You don't have a negative fifth term. However you would put that. You guys get 10, right? So n has to be greater than or equal to 9.
Oh, shoot, greater.
Because n is outside. So how many terms do we need? Careful. What did we not think about? Yeah. They don't want it to be 0.001. So what were we saying? Oh, you're okay to be less than or equal to, but they said, we don't want it less than. We want it less than. So the theorem says less than or equal to, and they're right, but the problem is they particularly said, no, just less than. So let's go change all these. Now careful. If n has to be greater than 9, then 10. Does that make sense? So we need 10 terms. There you go. We'll say at least 10 terms. We'll say at least 10 terms. Does that kind of make sense? Uh-oh, is it a homework problem? All right. Kiddos, I'm done with section 9.5, homework number 41. However, ooh, hey, you guys had some fun ones, didn't you? We're going to get ready for section 9.6. However, I'm not totally against, because you guys already know the odds in the sense of being able to check the answers, etc. Wait, yeah, calc chat, done. Is there anything really quickly that you guys want to ask as far as where you got stuck? Yeah, where are you at?
Well, it's actually kind of 2 questions, but one's on 9.1. Because there was like a question on 9.1 that I was kind of confused about.
That was the sequence section, right?
Yeah, and it was just weird because it asked us to, it said write an expression, and then it gave us like 4 terms. But I don't get their answer, but I didn't get their answer. Mine was really different. And then I also have a question on
It might still work, though. Which one was it? Number?
I'm sorry, 49. So it's like, they put n plus 1 over n plus 2, and I just have n plus 1 over n plus 1.
Oh, n plus 1 over n plus 1?
That's what I have, but their answer was n plus 1 over n plus 2.
N plus 1 over n plus 1 would be good, except remember your n's always have to be the same number. So if you're starting at 1, 1 plus 1 over 1 plus 1 would be 2 over 2. You were thinking of, oh, I can start at 1 and start at 2. No.
Yeah, sorry.
Does that make sense? There you go.
And then my other question was number 49 on the 9.5. It was like a weird,
All right, kiddos, if you have not gotten up to number 49 on section 9.5, you can go in the back of your homework spiral. Otherwise, you can just be sitting tight and paying attention, or you can be zoop, 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 zoop,
it's like,
daydreaming. Otherwise, shush. 49, right, kid?
yeah. And so I got that it converges based on the alternating test, but I didn't know if it was absolutely or conditionally, because I don't know what to compare it to.
Perfect question.
When I tried comparing it to 1 over n squared, like it was supposed to be last time, I just got
All right, guys. We checked in. Good job, groups. Both groups checked in with people that were gone. Welcome to the class. I'm glad you're doing well. Did I just give you a peek as to what we might be dealing with in section 9.6? Yeah. What do you see? Factorials and roots. So wait. Could homework 9.5 have been hard whenever you saw a factorial? Oops. Yes. So we're going to talk about it before 9.6 just for a second, and then we're going to be like, oh, but 9.6 is coming. I think it's going to make everything easier. Okay? So Maggie was saying, you know what? I could do 1 and 2 for the alternating series. Hopefully you guys would have been able to too, because limit as n goes to infinity of is. So 0, check. And then I just care about whether or not 2 times n plus 1. Now you guys are putting n plus 1 in the right place, right? Inside the variable. Is that less than or equal to 1 over 2 times n plus 1? Yeah, because he's going to have more, right? We'll talk about what kind of more in a sec. But that's a true. So he does converge. But what was Maggie asking?
I guess is absolutely.
How do we do absolute convergence? We can't do the alternating alone, right? We have to look at what if the alternator wasn't there. So did you guys think of what test you could use in order to help you consider a factorial?
And then I tried direct.
Comparison's the only way, because can we integrate a factorial? Is it a geoseries? P series? Nth term? We know nothing. I agree with comparison, and I agree that limit comparison is the easier of the two. Who's going to win? Factorial is the fastest growth, even above exponential. I mean, especially if I compare to linear or quadratic or anything else. So the bottom's always going to win. The limit's always going to be 0. And limit comparison, limit 0, only helps if I'm comparing to. So why not just compare to? N squared would be convergent. When I take the limit and I multiply by n squared over 1, I'm going to get 0. Limit comparison says. Now, I wrote this really messy, and it's not very detailed, and they could probably take points off. But converges, a.k.a. It's a good guess, kid, but just be careful. Yeah.
Do you have to brush it off? Or does it matter which one's growing faster? That doesn't matter for this test, right?
Limit comparison, don't care. Well, we care about the degree and who's stronger eventually, but we don't care about one being bigger or smaller for every single term.
Okay, so it's just different.
And also just wanted to note that 9.3, there's no number 79.
Oh, yeah. Naomi told me that. Just skip anything that's weird as far as going back. I think I didn't copy off that page. I'm sorry. All right, cool kids. Here's the nice thing. From here on out, anytime you see a factorial, I want you to think ratio test. So here we go. Let's figure out what's going on. Wait, there are no series. Why? Because factorials are tricky, so we better just do some pre-cal review. What does number 1 equal? What's number 2 equal? What's number 5 equal? Oh, I don't know. We'll get back to that. Anyway, number 1. If I were to ask you how to find 5 factorial, what do your brains do? I need to know this. What do your brains do? 5 times 4 times 3 times 2 times 1? No, you can't freak out. 5! And then you have to think of, no, there's math. So, 5 times 4 times 3 times 2 times 1. It's called a factorial.
Oh, no, I meant like the answer.
Oh, I think it's 120. Yeah. I want you guys to think of factorials the other way. Why? Every factorial in a different place, but every factorial begins in the same place. So instead of doing 5, 4, 3, 2, 1, like 1, 2, 3, 4, 5, because then 3 factorial, 3, 2, 1, oh, 1, 2, 3. Why is that something? Won't anything shared just reduce? But where does he stop? K. Where does he stop? K plus 1. Where's K plus 1? 1 past K. Oh! He's left. So you guys do number 3.
Is that supposed to be a factorial?
2n factorial, 2n plus 2 factorial. Count up by ones. Count up by ones. I need water. Where's water? I mean, I guess 1 times, yeah. Is that 1 times?
So I was thinking, like, if the first term is 1, wouldn't the first term on top be 2?
Because all factorials, wherever they are, always count down to 1. 5 factorial, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. 11 factorial, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. They all go back to 1. Where does this one end? You guys agree? N in factorials are like n's in sequences and series. They're always whole numbers. So this one goes up to 2n, but doesn't he keep going? So add 1, go 1 term more. Oh, 2n plus 1. Add another one, 1 term more. Oh, 2n plus 2. Factorials. Every next number in a factorial. Add 1, add 1, add 1, add 1. Try to whisper, guys. Try to whisper, guys. Try to whisper, guys. Add 1, add 1, add 1, add 1. So add 1. Oh, 2n plus 1. Add 1. Oh, 2n plus 1 plus 1. Add 1. 2n plus 3. 2n plus 4. 2n plus 5. Basically. Number 5. Oh, why is it so hard? Isn't it just n to the 1 over n? It's infinity to 0. Ooh, special converging. Yeah, I think so. Isn't it 1? Double check. Double check. Not everything is 1 when it's infinity to the 0. According to our special converging sequences, James Calvin is saving us with the forever. You guys know what I'm talking about, though, right? The Endeavor card with special converging? Yeah, it's 1. Hey, guess what? That's all I need to know to do this section. Kind of. Maybe a few more things. Ready, set? Oh my goodness, they're both in 1 card? 2 tests in 1. 2 R's in 1. Parting C. All right, and go ahead, kid.
Justin had a question about factorials. Since you know that it'll always equal 0, is there ever going to be a factorial that like the limit test? If you did the limit comparison test with factorial,
Oh.
Is it always equal 0? Is there ever going to be?
Always equals 0 unless you have, then not always 0.
So if you don't have that, like if you just have like some over factorial, doesn't that, will that always converge? Is there ever going to be one where it doesn't converge?
If you have a constant over a factorial, you will always be able to do limit comparison test with a convergent showing convergence, yes.
So those will always converge?
If it's a constant over a factorial, yeah. Unless the factorial, well, I just showed there can be factorials on top of factorials. You can memorize that. You can memorize. And my weird that I don't know how to write that. I'm not sure I've ever seen that.
Sometimes like I do converges and then I just look at the series and I'm like, oh,
Does anybody know where we are? 24? 25?
It's 23.
Oh, I got off somehow. Ratio and root. Hey, series have positive terms. If they don't have positive terms, they're either alternating or they have negative terms and the negative can come out. Or, well, or maybe nth term, diverge. Anyway, Positive terms for ratio and root. The nice thing is with factorials, they're always positive numbers because it's 1 counting up to whatever positive number is in the factorial. I guess there could be a negative in front, like multiplied in front. That's awkward. Cool kids? Yeah, there you go. I'm not sure anyone just thinks of math. It's always a search. Always a struggle. There's almost always a problem that needs solving. And then there's someone asking the question, but why? And then the why, ooh, that's a rabbit hole. You guys seen this is talking about taking a limit of a ratio or the limit of a term to a root or to a fractional power and getting a constant? Wait, does L always have to be a constant? L is less than 1, so something, well, this is positive, right? So L is less than 1 would be something between 0 and 1, including 0. L is greater than 1, well, it can be any sort of constant, including infinity, or L is equal to 1. Oof. What do you guys see with L equal to 1? Mm-hmm. Mm-hmm. But it's really nice to use with factorials or nth powers. Because, I know. This one, some of you were like, oh, hey, why don't you use limit comparison? And you could. But the other way is you could just say the limit as, because all the terms are positive, n going to infinity of a sub n plus 1, or 1 over n plus 1 factorial. All over n plus 1 factorial. Every time you're going to have multiplied by the reciprocal. We'll just start doing that. 5. Oh, hey, up to n factorial a little bit further. This is going to equal 1 over n plus 1. This is going to equal 0, which is less than 1. Yay, it's convergent. Dun, 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 dun. Dun, dun. Anyway. Ooh, n to the n over n factorial. Ooh, that's going to be a party. I said any x e to the n loses to n factorial, but I never said anything about n to the n. We'll have to see that one tomorrow. Bye, guys. See you later. Who's stronger? Cliffhanger of the day. Mm-hmm. I was plugging into the first one. A sub n plus 1 over a sub n. And then 1 up to n plus 1, 1 up to n, 1 over n plus 1. Ooh, I did what you guys did.
Are you kidding me? Drop box, no.
Sorry.
It's never gonna be the same. I can't believe you just did that.
He's so picky, this guy. Bye, guys. Was it about this test?